Hi guys, welcome. My name is Krzysztof Hermut, like Kuba mentioned, and I'm a front-end developer in PROIDEA. We are a startup, we are disrupting the art market worldwide. And today I'm going to be talking about a function called ECMA-262 specification. And we're going to be talking about contracts and a couple of disclaimers to start with. First of all, we won't be doing it. This talk is going to be implementation agnostic. It means like we won't be looking at the code that actually runs your JavaScript code, aka like a spider monkey, so on and so forth. This talk is based purely on specification. So we can imagine that this is 1960s and we just have to do something, and the only source of knowledge is going to be a specification of a language. This is like a upper intermediate level of a talk. So I assume that you are like a seasoned developer and you have working knowledge of JavaScript. So for you, like things like bindings, identifiers, functions, so on and so forth is basically like everyday bread. Also, this talk, because we are going online, so I kind of like adjust the whole talk to what we're gonna have at the moment. So it's based on a couple of layers. The first layer is going to be slides. The slides are available and where you will see whatever I'm presenting here at the moment. So those slides are divided into three main sections. The first section is title, and the title corresponds to the actual ECMA specification subject as well. Also, we're going to have some quotes from the specification, so we're going to use them as hooks for this talk. Also, underneath, you're going to have a link, and if you're going to click the link, it's going to take you straight away to the specification. Also, on my site, you can find learning resources. This is kind of like it might be helpful for you to understand things that I'm talking about. We won't be using that. It's just like a fallback because happily today, ECMA is rolling new draft. So their servers are kind of laggy. So we might have some issues with going through the specification. I have that already loaded, so there shouldn't be any issues. Also, we're gonna use external resources. We're gonna use AST Explorer, which is we're gonna use for visualizing abstract syntax tree, and also we're gonna be using Chrome DevTools for some code samples. Okay, so this is basically a start, and next major thing is what's the flow of this presentation is gonna be, and the flow is gonna be that we're gonna go through the slides. We're just gonna go back and forward because our aim for today is to understand this script. This is a simple script, as simple as it can be. We're going to use it inside out and starting with a source text, and then we're going to end up with returning a value during the runtime for function foo. So I don't want to overcomplicate it. It's just as simple as it can be. Okay, so let's get started. Hopefully you are excited as much as I am. Okay, so first things first. When I started working with specification, ECMA specification, that was kind of like a long journey because you cannot find many resources on the web that will help you out with understanding this kind of stuff. It's just like a technical documentation, so we have to like deal with that. So to start somewhere, we're gonna start. And conformance tells us that a conforming implementation of ECMAScript must provide and support all types, values, objects, properties, functions, and program syntax. Okay, so what does it mean? If you are a guy that wants to create a JavaScript runtime, you have to, the specification is for you. So basically all the rules, all the types, all the data structure, you have to implement them one-to-one. If you're gonna have any exceptions, basically, this is not JavaScript. This is not ECMAScript 262. You can add your own stuff. For example, browsers will add some stuff to Realms. We're going to talk about it later. Node.js add more stuff, but all the things that are being specified in the documentation, they have to be implemented. Okay, and then we have got another quote, and that quote said a conform implementation must interpret source text input in conformance with a Unicode standard. Okay, so let's have a first look at our script. And what we know from conformance is that we have got basically a source text, a Unicode source text, and we do not really know much more about it. So let's dig deeper with that. Okay, so source code. Source code is expressed using Unicode. We already know that. And source text is a sequence of code points. Cool, nothing really interesting here, really basic stuff. And this is quite basic and important from the point of that JavaScript is just-in-time compiled. And when we are talking about just-in-time compilation, it straight away tells us that there's no like ahead of time compilation. So we just like sourcing our source text into the virtual machine, and that virtual machine is responsible for doing two things. It's responsible for parsing our code, and it's responsible for running our code. Okay, so now in a parsing phase, let's name it. Also keep in mind that sometimes I'm really oversimplifying things. This is because we have like quite a huge subject to cover, and there's a lot of like edge cases, a lot of things that you would like to know maybe, and maybe you're gonna dig deeper, but I'm just showing you around the specification and just taking you through the whole flow. Okay, so now we have got only one thing that we know, this is source text. And with regard to the source text, there has to be some kind of a grammar. If you like a Polish guy, Ukrainian guy, English guy, you have got your own grammar, okay? And this is basically a set of rules that will tell you that a given, let's say, set of characters means something, okay? So if I'm sending a letter to someone, for example, Mateusz Wojciak was talking about the same example, okay? Like you put it on the table, put it in the fridge. If I'm gonna send it to Indian guy, there is 100% chance that he doesn't speak Polish, and he won't be able to understand that. Okay, so lexical grammar is a sequence of input elements. And this is really important because this is where the actual source text becomes a source code, okay? So your code is being compiled, you're gonna have tokens, line terminators, comments, or white spaces, okay? And the next really important thing is that the source text is scanned from left to right. Repeatedly taking the longest possible sequence of code points. Okay, cool, it kind of like makes sense. A lot of us already know, like all of us already know how our code is being run. So for you, just if you're gonna get bored with my presentation, you can try, you can just answer the question, okay? What the result's gonna be and what the actual B identifier is gonna be bound to after that, after that binary expression here, okay? Cool, so we have got source code, and now what else? Syntactic grammar, we already covered it. Another question is it possible? Will it compile? Just keep in mind that this is not a strict mode. So this is outside of the strict mode. Lexical grammar, everything's kind of clear at this point. Okay, cool. So just to going back to the actual example, we have got variables, we have got assignments, we have got function definitions, okay, and specification will tell you everything that you need to know from the point of view of syntax. So function declaration, how it looks like, you're gonna have a function token, you're gonna have a binding identifier, so this guy here, okay, and then you're gonna have format parameters, function body, really simple stuff, like a really entry-level stuff for all the guys that are learning JavaScript. Okay, so what's happening next? Because now we only know about our abstract, about our source text, and at some point, and this is, I'm also simplifying things, your source code is going to become an abstract syntax tree, and for that, just to show you around, we can move to astexplorer.net. You can just put whatever code you want over here, and if you're going to be highlighting parts of your source text, we'll know what types we're going to have here, what structures we're going to have here. That also can be converted to JSON. So over here, we can have got like a variable declaration, really simple stuff. Over here, we're going to have, let's say, an identifier, assignment, number literal, so on and so forth. And over here, just to tell you that I'm telling you the truth, we're going to have a function declaration, we're going to have params, and also we're going to have body. Okay, cool. Nothing exciting over here. Let's move forward. So now when we're going to go back again to our example script, we can reason about it and see, okay, so I know what it's going to be, so, but how is this being grouped, okay? And in JavaScript, we have got 4 types of source code. We have got global, function, eval, or module code. And if we're going to open this actual specification, this is going to be the first time we're going to open it. So it might take a while. Let's be patient, just in time. Maybe we're going to be lucky. Cool, we got lucky. We can have a proper look at the specification. A lot of, just keep in mind, when you're going to be dealing with specification, that don't be forced to read everything. There are really nice sentences that are explaining a lot of stuff, and dealing with the technical documentation is mostly that you're getting as much as you want at some point. You don't have to go through everything. Okay, so let's try to understand what the function code is. So function code is a source text that is parsed to supply the value of, and now we have like massive break, because I don't have an idea what an ECMAScript code is. I don't have idea what formal parameters are. Like I know what that is, but before the between those parentheses, internal slots, function object, I don't know nothing about it. So let's take a step back and let's go back to the global code. Okay, and the global code is like a source text. Okay, so we are solidifying the whole notion as a source text. And what else? It tells us that the global code of a particular script does not include any source text that is parsed as a part of a function declaration, as well as function expression, so on and so forth. I don't want to add too much stuff to this talk, so we're just going to be focusing on function declaration. Cool, function declaration. We already know what the function declaration is. Function definition, function declaration, cool. But what exactly does it tell us? It tells us that because JavaScript is just-in-time compiled, so we have got a first really massive rule, and the rule is that when I'm in the global code, okay? So when I'm going to be compiling the global code, I won't be creating any resources for execution of foo, okay? I'm just going to take the formal parameters, I'm just going to take the body, put it somewhere, and keep it for the future reference. And I'm going to create the whole infrastructure only when foo is going to okay, ever that it's nothing magical about it. But there's another question, because speaking about infrastructure, we have to know that our code, whatever is it, just like a really complicated module or just like a one line of code, it's not evaluated or compiled in. It's not evaluated. It's getting compiled, but it's not evaluated in a vacuum, because before it is evaluated, all ECMAScript code must be associated with a realm. We won't go just in depth with realms. It's a really big subject. Like a lot of subjects that are coming from the specification are big. So we just, like I said, we just like cutting corners with that. But we have to know that there's something called realm, and that realm provides us with what? With intrinsic objects. I'm just going to tell you like a couple of words about them over the course of this presentation, and the global environment. Okay, the global environment is quite important over here, because this is a bridge between global code and actual things that are called environment. Okay, and we have got ECMAScript code that is loaded within the scope of that global environment, so on and so forth. So now maybe we're going to have a look at the actual code, and let's say we can go here and we can just run it. Okay, so over here we just with a simple debugger statement, and we in the global environment, in the global code. So the global code has got something called global environment, and I'm showing you that only because I want to show you the intrinsics, and the intrinsics are basically a building objects, like objects, arrays, functions, so on and so forth, and you can see them over here. For example, what we're gonna have things like, let's go a little bit further. We're going to have a lot, a lot of this stuff is coming from the browser. So the engine that basically runs your JavaScript code in a browser puts its own stuff onto the realm in form of the parts of the global environment. But over here you have got map, you have got map, JSON as well. You're going to have object strings, so on and so forth. Okay, so let's take it back. Source text, source codes, abstract syntax trees, variable declarations, function definitions. And then when we are starting to execute our script, the realm is being created, and for the global environment. So, and the global environment is created for the global source code. Okay, so but what is exactly the global, what is exactly the lexical environment? This is a really good question, and we're going to be touching a notion of closure. And this is one of the takeaways for you guys that I would like to take from this presentation, because the lexical environment is basically a really simple concept that allows you what? And allows you to identify the association of identifiers to specific variables and functions. Okay, so let's go back to our example script, and we will see that we're going to have a global lexical environment. And that global lexical environment, by just looking lexically on this code, okay, we're going to have two identifiers, A and foo, okay? And we assume that there's going to be something created for the function. Of course, we have got something called function environment record. Keep in mind, we also have a global, the types of source code, we're going to have global, and we're going to have function as well. Okay, cool. This guy is here. So what else? If you're going to have a look at the function environment record, it's going to basically what it's going to do. It's going to tell you the same thing: associations of identifiers to their values. Okay, cool, great. So maybe now we can open the specification to have a proper look at lexical environments or environment records. Specification will give you a notion. This is a specification type. Will give you a notion of a record, and you should look. You could see the record as just an object because record is a collection of fields. It's a set of fields because they are unique. And now we are looking at function environment record. Okay, and the function environment record holds how many fields? About 5 fields. But it's not important at the moment because now let's go back to the example script and let's try to compile it and let's try to run it in our minds. Okay, so now the question is, we have got global. Okay, so now we're trying to execute full and we're not looking at the specification at the moment. We're just doing like an old way of like a technical interview and somebody is asking you just to tell what's happening in the code. Okay, so now we're gonna have a binary expression and we just want to add B to A. Okay, so now we have got an identifier. So my assumption is I have got an environment record that will hold the association between B and 2. So once I'm gonna be we'll get 2. Simple enough, nothing complicated here. But now what about this guy? Because when I'm consulting function environment for the function foo, I'm asking it, listen, do you have A? And the function environment is telling me, no, you don't have A. So now what's going to happen next? And this is basically what that is. It's like closure by itself. This is how you should be explaining closures to other people. This is how you should be laying closure in your head. Because every environment record has got, and record is a collection of fields, aka this is just like an object. Oversimplification, I know, but you can imagine it like this, has got a field called outer environment. Okay, great. So that outer environment points at the outer environment. And if this is a global environment, the pointer is just null. Okay, it points at the null value. So now, using this dynamics, what we are doing, this environment record doesn't have A. So I'm asking, hey, outer, do you have A? Yes, I have. Can I have the value, please? Yes, here you go. 1 plus 2 is going to equal 3. And this is a closure. Okay, so let's stick with it because we're going to solidify it later on. So environment records, now we kind of like know something about them. This is function environment record. Now we know more about it. So let's have a look at the specification. Table 17, then we can have like a little break here. We won't be reading that. Just a quick takeaway, if you're going to be learning about this. So this value is only on environment records. So if you're going to be looking at this value, you always have to think about environment records. There are different slides on my site. I've been doing talks about this as well. I strongly encourage you just to have a look at it and maybe you can get something out of it. But one of the fields that I have got on environment record is function object. So I can remember this guy from, let's see where that was. I think that was somewhere over function definition after Python source code. Okay, as you can remember, we had the thing called you have got a function, function code, and that function there was like we can remember that it was mentioning function object. Okay, so we kind of like going back and we just like connecting the puzzles all together. Am I right? Yes, there was something called function object, and specification from time to time is going to give you those useful links. So we can just click it and see, okay, so there's another table, there's something like call, so you can get that from the title of my presentation. And then we have got construct, but now we're going to have to take another step back. Why? Because the function object, if we are dealing with a function object, it means that it's an object. And Carl's been showing you at the first presentation, I know have you seen it, he's been talking about proxy. And he was referring to things that have been called like internal methods. Okay, and the internal methods, he's been putting traps on those internal methods, and he's been basically what he's been doing. He's been like hijacking get and set, and then he was able to console log something or just like throw an error, so on and so forth. Okay, so now I would like, this is another takeaway that I would like you to get from the talk. And this is that you should look at objects in JavaScript on 2 different levels. Okay, the first level is basically the everyday level of having like a proper collection of properties. Okay, we can have data property, accessor properties, We can define properties, we can be deleting properties, so on and so forth. But underneath the surface, you have got another thing, that basic algorithm. Basically, the algorithm is going to be giving you according to ECMAScript. And those are internal methods, okay? Internal methods that have got their own semantics. So for example, what that can be. So another look at the actual ECMA-262 specification, up to date, draft up to date. So we are really lucky. And we are waiting for the specification, because might take a while. Now we're going to try to scroll down. Cool, yeah, so those properties, okay, we're not interested in this. Here we are, essential internal methods. And now you can just something mentally should click in your knowledge right now, because as you can see here, those internal methods are being used to do your everyday stuff: get, set, delete, on property keys, get prototype off. So every time you're doing something in JavaScript, for example, getting a property. So let's just have a look. Here, okay? A to B, those are properties, but if you're gonna go here, for example, proxy, this is an object, this is how I am assigning the actual property value. So I'm using the internal method called set. Okay. Go back to the actual function object. And the actual function object, what specification will tell us is that the actual function object is a callable object. So this is an object that you can call, and it just means that you can use an internal method called call on that object. Okay, cool. So maybe we're going to be lucky, and we're going to be able to see what that internal method looks like and what it should do. So for now on, it's like a kind of like a gentle introduction to call. We're gonna be going through the steps that are being performed when the call is being invoked at the end of this talk. But now, for our reference, the most important stuff is this description. And as you can see, like specification is not that hard to read. It's basically human readable. There are parts that are really complicated, but majority of the stuff, like 80% of the stuff, is meant for the implementers of the specification. And for us as a consumers of the language, it also is really gentle, and it really allows us to understand a lot of concepts and a lot of mechanics behind it in the form of descriptions, so on and so forth. So we have got a callable object, aka function object, and it has got an internal method code. What does it do? It executes code associated with this object. Okay, so where is that code being put? That's another question. And it's invoked via function call expression. And keep in mind, function call expression, everyday stuff for all of us, is this guy here. Okay, so going back to the actual where we are at the moment, we know source text, source codes, function definitions. We know something about the association between source code and the actual lexical environments. We know that we have got something called outer environment that points outside of the actual environment. And now we have got function call expression, and this is a function object. Okay, great. So let's go back where we at. We're here. Okay, so what is a function object? The definition is going to be function object encapsulates parameterized ECMAScript code closed over a lexical environment and supports the dynamic evaluation of that code. Kind of like a specification mambo jumbo, and because the really interesting stuff is over here. Let's look at the specification, and maybe we're going to be able to have a quicker look at it, because there's a really nice table that will show us what the internal slots of ECMAScript function object are. Because now we've been only talking about internal methods, but there's also a thing called internal slots. And just a quick disclaimer before we're going to start reading this table. And the disclaimer is that your function object is being created here. So your function definition, your function declaration, creates a function object. So let's have a quick look at what's happening in the code. Environment record nesting, we're gonna have a look at that later. Can we get like a proper, yeah, let's go here. Let's scroll up. And keep in mind that we're still in the global code, in the global environment. As you can see here, we're just gonna scroll down, we have foo. A foo has got 2 layers. the layer of prototypes and own properties. We already know that. Length, name, so on and so forth. Of course, you can add any properties to your function. This is just an object, so you can have all those get, sets, delete, so on and so forth. But we didn't execute, we didn't evaluate the function, but we already created the function object. So this is the visible like a layer of a function object, and this is going to be an invisible, let's name it, layer of a function object. Okay, and what we have got here, we have got multiple internal slots. But as you can see here, source text. And does it tell us something? Yes, it tells us a lot, because when we've been talking about global code, we got to know a fun fact that your code, basically your body of a function, is not being parsed, but it has to be stored somewhere. So when the function object is being created, the source text is being a part of one of the internal slots. Okay, and then when the actual function is being compiled, the source text is being parsed into the ECMAScript code. As you can remember, for the function code, it was referencing to the ECMAScript code. Also, we're going to have formal parameters. Also, we're going to have strict. So we're going to put this as a boolean. So it's going to take are we in the strict mode or not. Also, we're going to have a this mode. So this mode, this is also quite interesting in terms of this, but only no, we don't use strict using all the. But you're going to look here. We have one of the most important on a function object, and this is environment internal slot. And what that means is that when the actual function object is being created, okay, we are getting the environment, outer environment, as a part of a function object. Okay, so what does it mean? It means that the outer environment for this function will always be global. Okay, it doesn't matter if I'm gonna get that function object, put it on a different object. It doesn't matter when I'm gonna call this function. The outer environment will always be global. If I'm gonna create a function here inside of the foo, the outer environment for, let's name it pass, it's gonna be always foo. Okay, so it doesn't matter if I'm gonna move it to an environment where, or call it in an environment where a means, for example, 25. No, for every execution of foo. Okay, dobra, sorry. So sorry for that, guys. I just got a notice that I'm not showing you the actual code in the debugger, so let's just keep it for now. Let's not make waste time. So I'm just going to be using this script. So let's just go to the actual presentation. Sorry for the interference. Okay, so as we know, wherever you're going to be shipping and wherever you're going to be calling the function object, the outer environment will always be global. So the actual place in your code when you are defining the function, this is where you're going to get your outer lexical environment. Okay, so environments, format parameters, code, so on and so forth. Let's go back to the presentation. We are getting more and more puzzles, and then we are kind of like getting ready to wire everything up. And to wire everything up, we're going to have a proper look at the call internal method. Okay, so let's wait for the specification to load. And while we waiting for the actual specification, we can. I can just highlight you one more thing that we are missing. We are missing execution context. And because I won't be able to show you the actual execution context using the debugger, unfortunately, sorry for that, guys, I'm just going to have to talk about it. More so, we're going to use for the explanation what the execution context is. We're just going to use specification by itself. Okay, but let's go back to the actual code. So what's happening here in our code? We have got foo as a function object, and now we are trying to call. This is a callable object. It has got an internal method call. So we are able to do that. And there's a simple assertion at the beginning of our journey, which is a function object. Are we compliant with that assert? Yes, we have got a function object. Sometimes you have got an error in your code saying it's not a function. This is exactly what's happening. Okay, so if I'm just using an object that is not a callable object, you don't have an internal method call, you can do that. Okay, then we have got class constructors. And just for you guys, like as a takeaway, Classes in JavaScript are built on top of constructor functions because the function object can be treated in two ways. It can be treated as a callable object, but also it can be treated as a constructor function using new syntax. You can have a look at it by yourself. Everything's being well explained in the specification. Also, object like objects number, the things that I've been showing you, or at least I tried to show you, they are also in vast majority constructor functions. Okay, so point 3, we have got something called color context, and the last piece of puzzle for us is going to be what the execution context is, and I've left it for later, just till the end of this talk, mostly because of the fact that vast majority of us is aware of the existence of a call stack. Pretty simple interview, entry-level interview questions, last in, first out, and stuff like that. But in actual documentation, it's referred as an execution context, and is being structured as a simple queue. You can name it, and just putting new frames on top of the other frames. So, and it also has state components, which are pretty simple. We're going to keep a function object. This is a function, aka function object. We already know something about function object. And also we have got a code evaluation state. What is it used for? Because environment record and execution context, there are two main devices that are allowing you to run your code. Okay, because now we're going to have a separate execution. Yes, and for the global, it's coming here, and then it gets suspended, but it keeps the actual where it is, because we might resume execution of this execution context later on. I might have like 10,000 lines of code there, and just proceed with my program. Okay, proceed with my procedures. So I'm just running the global code. Now I'm just suspending it here. Okay, and then I'm just creating a new call stack frame, pushing it on top of the stack, and then creating a new one, and then I'm running the body of an actual function. Okay, but is it true? Is this the same as specification status? Okay, so sorry. So now we have got the color context. So the color context in our example is going to be, let's say it's going to be global. Okay, so now what's going to happen there? The color context is the running execution context. Cool. What else? So now let the call context be. Okay, and we have to go inside of this method. And what is happening here? Over here, there are happening two really important things. The first thing is that we are creating a new execution context. Okay, so by that, we're going to have a new execution context. It's going to have those 4 state components. It's going to have rel, so it's going to have every context has got access to all those resources that the actual engine is giving you. So this is quite useful. Also, it's going to have access. Our full will have access to the function object, and just stay with it because this is really important. And called evaluation state, it basically knows what's happening inside of this execution context. Okay, cool. Let's go back. So we are creating a new execution context, and then the point 8 tells us that the new function environment will be created. Okay, so I already told you that the source code is related to the actual lexical environment, but the concrete memory representation of your environment, it's only created now. Okay, when you are executing your function. So let's go inside, because there's a really nice thing in point 10 that maybe just gonna allow you to get like a wow moment, I hope, because as you can see, I already told you that every lexical environment has got a field called outer environment, okay? And that outer environment, on actual environment, is populated for function object environment field, and this is being populated when the actual function definition is being created. And this explains why lexically you can reason about environments, and why environments are called lexical environments. Okay, so let's go back. And over here we have got what? We have got lexical environment that's being created. We have got new execution context. And now what is happening? The caller execution context, if it's not already suspends, it retains its state. So what it does is it knows how to and where to go back. And then we are pushing the new calling context onto the execution context stack. Okay, and pretty simple. So now that execution context stack, I would like to show it on the code. Unfortunately, That won't happen, but we have got our call stack has got 2 frames. And the first frame is going to be for the global, and then the second frame while we are executing this function. And this frame is being pushed onto the call stack. Great, let's go back. And then what we have got another assertion that the call context is now the running execution context. We already know that. And then we have got ordinary call bind this. And we won't be talking about the mechanics of this. Just a wee takeaway for you guys is this is an expression. Maybe at some point you're going to remember what I've told you, and maybe that's going to be a guiding light for you. Unfortunately, we don't have time to go in depth with this. We just have to assert that this after 0.6, this is going to be set. Okay, and then we have got what? We have got ordinary call evaluate body. So only now, this is the first time when the actual engine is starting to proceed your function script. Okay, and also as you can imagine, there's quite a few quite complicated mechanics on that. I just have as the last part of this slide. This is an actual reference to the part of the specification that will show you that how many steps the actual engine has to take to give you to evaluate the body. Frankly, I never read it. I just had like a long time ago. I just had like a quick glimpse through that. But once you are things like ECMA-262 codes, normal parameters, and so on, and you know what the variable declaration is, and that kind of stuff, it's really rewarding just to be able to address those informations. Okay, cool. So, but let's just wrap it up and let's go back to our call internal method. So after the ordinary call evaluate body is being processed, we are going back to the point where we are ready. So we are returning. So we are ready to return the value out of our procedures using the return statement. Okay. So once we are ready to do that, we can just pop because before the actual value is being returned from the function, the execution context stack is being popped from the stack, and we are resuming the caller context. So now we are going back here, and this is where we're going to terminate our whole procedure. But like I said, we might have like a quotes when we are doing other stuff, and this is how we earn money. This is how we are dealing with our code, and then we are returning the actual thing. And if you're not returning anything, we have got 0.11 return normal completion undefined. So ECMAScript is basically telling you, okay, cool. So if you're not returning explicitly anything, I'm just gonna give you undefined. And to wrap everything up, because I know that there's a lot of digest, and this is kind of like challenging, especially for guys that haven't been doing this kind of stuff before. We always start with a source text. Then we know that that source text is going to get compiled, and at some point we're going to have something called abstract syntax tree, a massive simplification. But if you want to play about with it, I strongly encourage you just to copy paste your code and get to know with notion of identifiers, bindings, rebindings, expressions, variable declarations, so on and so forth. Solidifying the knowledge is not about like a showing off that you can talk about your code using some fancy wording. It really makes so much easier the whole thing of learning JavaScript and just knowing stuff. I can assure you that if you want to understand this, for example, the best way of learning this is just by looking at the specification. And I know this is a hard task, but I just used Clojure just to show you that even the more complicated things like Clojure, it's really fun and it's really relatively easy to understand using the specification. Because now we started with the source code, and then we went over the lexical grammar and function declarations to the types of source code. Then we know that we have got two primary types of source code, global and function, okay? We had like a quick break with realms, and then we started doing the environment records, okay? And now you know that an environment record is going to be created during the execution of the function, but now you know that you can identify the actual lexical environment by looking at your code. And now you know that every environment record has got something like outer environment. And that environment is getting populated from the actual function object. And that function object gets the outer environment lexically wherever it has been defined, not called, but defined. So this is a clear distinction between runtime mechanics for this and like static mechanics, syntax mechanics for closures. We also now know that there's something called object types, which is really obvious for everybody. That is a collection of properties, but also it has got things like internal methods and internal slots. You can always go back to the specification and have a look at the simple table and see, okay, so what have I got there? Okay, this is really simple. And then we have got something like a callable object. So if you want to go fancy during the interview, you can always say that a function is a callable object. And I guarantee you that there's going to be people that won't know what you're talking about. And it has got, as a callable object, as a function object, it has got an internal method call and this internal method call is being well described as basically a set of steps that the engine takes to evaluate your function. And as you can see, this is quite rewarding. I hope that you enjoyed this talk as much as I did. And because we still have, I don't know, maybe a couple of minutes, maybe 3 or 2 minutes, let's maybe, and I cannot show you that during the live coding, but we can just go to those examples and reason about it. It's quite simple. Here, so this is a conversion, change it to intrinsic number and convert it to 1. Okay. Then because this is 1, so this is going to be straight away converted as an implicit conversion to 0, and we're adding 1 to 0, so we're going to have 1. And then we have got pre-increment. So this is going to be an addition. This is going to be pre-increment. A points at 1, so pre-increment is going to be 2. So we have got 1 plus 2. It's going to be, is it 1 plus 2? No, it's 1 plus 3. So it's going to get, got lost with that. So we have got 1 plus 0 is 1, plus 2 is 3, minus, and this is a tricky part because this is what's going to be deducted from the actual 3. So the result's going to be, it's going to be 1, but then there's going to be post increment, and after execution of this expression, p is going to be 3. Okay. The next nice thing is this guy here. Yes, it is totally valid without a use script mode, at least for the latest specification. Let, it wasn't an exact keyword, believe it or not. You cannot go let because that won't be a syntax, because now if you're going to look at the actual productions, now we're going to have let, so it's going to expect an identifier, and then it's going to be get let. So, but for let, it won't be an identifier, but for let is totally valid. And I don't know where that was, but we had got that thing when we were creating, I think that was here, when we were creating this guy here. Yes, this is totally valid. You can create an object with a property that is an empty string. But another question is, how can I access it? And the answer is, you can just use computed property names just to invoke the internal method get on an actual object. Okay, guys, so thanks for attending. I hope you had a really good time, and let's go back to the studio.